Good morning, students. Welcome to my channel, VK Voice. In this session, we are discussing about the chapter 1, Force. In part 1, we have discussed about moment. We have discussed about the couple, their examples, that all things we discussed in part number 1. In part number 2, we discussed about center of gravity. We have discussed we have defined the center of gravity as well. Now some important terms in center of gravity. First term is center of gravity depend upon the shape of the body. As the shape changes, the distribution of the particle changes, hence the center of gravity also changes. So one thing, center of gravity depend upon the shape of the body. Why? Because with the change of shape, distribution of particle changes, hence center of gravity also changes. Now one more thing, keep it in your mind. It is not necessary that always the center of gravity lie on the material. It may or may not lie on the material of the body. For example, if you are having a uniform wire, suppose, then the midpoint will be the center of the gravity. But if I bend this wire in the form of circle, then the center of gravity will be at the center, and at the center there is no material. So in one point it is lying on the material, in other case it is lying not on the material. So one more thing, you just keep it. And then there are some regular bodies whose center of gravity you can calculate easily. You are having some formulas. For example, if you are having a solid cone, then the center of gravity of a solid cone is h by 4, where h is the height of the cone from the base. And if you are having a hollow cone, in that case center of gravity is h by 3, where again h is the height of the cone from the base. If you are having a square, you are having a rectangle, in that case the point where the diagonal intersect, for example, you can see over here, diagonal intersect, that point represent the center of gravity. Suppose you are having a triangular lamina, in that case the point where the medians intersect is the center of gravity. Suppose you are having a solid cylinder, in that case the center of, or the midpoint of axis of the cylinder is the center of gravity. So if you are having a regular body, you are having various formulas for the center of gravity. But suppose you are having an irregular body, then how you will determine the center of gravity? That you can easily determine. I will explain you with the help of a example. Suppose I am having this body. This is not a irregular body. I am having a regular body. But suppose this is a irregular body. Then how I will just check where its center of gravity lie? For that, what I will do, first of all, I will make 2 or 3 holes. One hole suppose over here, one here, and one. Many parts you can make holes. 3, 4, 5 holes you can make. So in that holes, put a needle which is having a plumb line with it, like this. Now put this needle in one hole. Suppose one hole is over here. Then you can see that the thread is moving over here on this body, like this. From where the thread is moving, make a line with the help of a pencil. Then put this needle in the other hole, like this. Again the line is moving from here, with the help of pencil you can again make another line. In this way you can make 2 or 3 lines or 4 lines. I have shown over here. Suppose one hole is over here, other hole is over here. One line is moving like this, other line is moving like this. Where these lines will intersect. Suppose these lines are intersecting over here. So this is the center of gravity. So very easily you can calculate the center of gravity. The main thing is what you will do. First of all, take the irregular body, make 2 or 3 holes, and then put the needle inside, make lines, and where these lines are intersecting, that point is the center of gravity. In this way you can easily calculate the center of gravity. Now center of gravity is complete. Now next topic which we will discuss is uniform circular motion. Now what is uniform circular motion? Suppose a body is moving in a circular path with a constant speed. If a body is moving in a circular path with a constant speed, then this type of motion is known as uniform circular motion. But one thing, keep it in your mind here, the speed is constant but velocity is variable. How? Because if I draw 4 points on the circle, 1, 2, 3, 4, A, B, C, D, I have just drawn over here, then you can see at point A, the body is moving in the upward direction. You can, if I just draw like this, north, south, east and west. Then at A it is moving toward north, at B it is moving toward west, at C it is moving toward south, at D it is moving toward east. So at every point the direction of motion is changing. Speed is no doubt constant, but direction is changing. That means the velocity is changing at every point. And you people know that rate of change of velocity is acceleration. So in a uniform circular motion, the speed is constant, velocity is changing. Since there is a change of velocity, so there is acceleration also. Therefore, uniform circular motion is an accelerated motion. Now with this, one question can be asked, what is the difference between uniform circular motion and uniform linear motion? So very simple. I have told you, uniform circular motion, speed is constant, velocity is variable, and it is a accelerated motion. But if you are having a uniform linear motion, in that case, speed and velocity both are constant. First point. And since velocity is constant, so there is no acceleration. So uniform linear motion is non-accelerated motion. Uniform motion is a non-accelerated motion. Uniform linear motion is non-accelerated motion. So this uniform motion, this is about uniform motion. Now next topic which we are going to discuss is the centripetal force and the centrifugal force. What is centripetal force? First of all, centripetal force. As you people know that if you just want to change the direction of the motion, if suppose one body is moving in a straight line, you just want to change the direction, what you will do? You will apply some force. That means without the help of a force, the direction cannot be changed. Similarly, if you see this motion, here the particle is changing its direction of motion at every point. That means the particles must be experiencing some force. And that force which is experienced by a particle which is moving in a circular motion is called centripetal force. Centripetal force is a force experienced by a particle moving in a circular path, and the direction of this force is always toward the center. Always toward the center. 2 points, keep it in your mind. When the body is moving in a circular path, a force is acting toward the center, and this force is known as centripetal force. Due to this centripetal force, the circular motion is possible. So there are few examples as well. For example, electrons are revolving around the nucleus. Why? Because the electrostatic force of attraction provided by the nucleus on the electron provides the necessary centripetal force. Similarly, planetary motion. Planets revolve around the sun. Why? Because sun is providing the gravitational force that acts as a centripetal force. Similarly, moon is rotating around the earth. And similarly, if you are having a stone tied with a string and you rotate it, again the tension is providing the centripetal force, due to which the body or that stone is rotating in a circular path. So these are few examples of centripetal force. Now next is, what is centrifugal force? First of all, keep it in your minds. Centrifugal force is not a real force. It is an imaginary or it is a fictitious force. This force is there to explain certain observation that we will discuss later. So what is this force? This force is first of all, this force is a assumed force. So force assumed to be acting on the body in a direction away from the center. In a direction away from the center of a circular path. That force is known as centrifugal force. One word you should always write: force assumed. It is not a real force. It acts away from the center of the circle. So this is the center. Now the question is why it is a imaginary force. It is there to explain one example, one observation. For that, suppose you are having a person who is sitting, suppose the person is over here. A person is sitting on a merry-go-round and he is having a stone tied with a string in his hand. When the merry-go-round is rotated, then the tension comes in the string and the string becomes tense and it moves with the person. So for the person, the stone always remain in his sight. That means the person who is sitting on the merry-go-round, for him the stone always appears stationary. But if a person is standing outside, suppose this M person is standing outside, for him what will appear? For him it will appear that the stone is moving in a circle. Now two persons are there, they are making the observation for the same phenomena. For one person who is sitting on the merry-go-round, the stone is stationary with respect to him. But for the second person who is outside the merry-go-round, the stone is moving in a circular path. So these two observations contradict each other. For person number M, who is outside, he will explain this observation as due to tension, a centripetal force is acting on the stone, due to which the stone is moving in a circular path. But for the person who is on the merry-go-round, two forces are acting on the stone. One is the tension and other is the force which is acting away from the center, that is centrifugal force. So two forces are acting. So due to which these two forces balances each other, hence the stone always appear to him as stationary. But stone, for the other person, stone is not, stone is moving in a circular path. So hence it can be proved that the centrifugal force is not a real force. This is the last topic of the chapter number 1, force. I just want to tell you, dear students, that I have just divided this chapter number 1 into 3 parts. Part number 1 is available on the YouTube. Part number 2 is also available on the YouTube. If you missed any lecture, you can just go through that and you can just make your concept clear. For your comment, I will welcome you. Thank you for watching my channel. Thank you.